In this video, we're going to look at using tallies to create frequency tables. And then from there, we're going to look at how to turn frequency tables into frequency graphs. So here are our learning intentions. You can have a quick read of them if you'd like. But yeah, we're going to be interpreting tallies, making frequency tables and frequency graphs. So a frequency table is just a way to show how common a certain value is in a data set. So as a class, we took some data just on various things that we were interested in, and we're going to turn some of them into frequency tables. A good way to do that is using tallying. You've probably seen it before, and let's have a look at some of our data. So we're going to start up here with the data we're looking at is from our question on what is the main method of travel that you use to get to school. So if I wanted to make a frequency table of this, first what I would do is I would put here, I'm going to put each of my different outcomes. Yeah. So first we've got bicycle. That's one of our outcomes. We've got car, we've got walk, and we've got tram. So those are our only choices here, right? The first little bit of our table, we're going to do a tally. There, we're going to turn that into a frequency. So next one down will be frequency. So with my tallying, what I do is I just go along and I tally things up. So I'll change color here. So bicycle, there's one there, right? Next is car. What I might do is I might do all the bicycles first and then go back and look at other ones. So we got another one there, another one there. So we got that one, that one, that one, that one. That makes 4. When we get to the 5th one, we strike through all 4. That'll just make it easier to count. And we've got one more bicycle. So the principle of our tallying is just do 4 in a row, strike through all of those to get 5, and then keep going from there for 6 and onwards. Just keep following that pattern. So here we've got car, just one for car, cool, all right. Then we've got walk, so we've got 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5, and one more, 6. And then we've got, the only thing left is we've got a single tram. Okay, from there, we can finish our frequency table by just writing in here, just counting up from our tally. So we've got 5 plus 1 makes 6, 1 makes 1, 6 again, and 1. Okay, pretty kind of similar data for each of our categories, at least in pairs. So what was the most common value in the class? Here we've got bicycle and walking were equally common. So right here, bike and walk. Is this useful information for this category? I would say yes, right? It's useful in terms of it tells us what students are most likely to do. So if you're interested in how you guys get to school, that is useful. How many students completed the questionnaire? Well, an easy way to do that would be to just kind of add an extra box here where we look at the total. So if I add up all my totals, excuse the messiness here, but we've got, so 6 plus 6 is 12, plus 2 more makes 14. So we had 14 responses to this question. So how many completed the questionnaire? I'm going to say 14. How many students were absent, had computer troubles, and didn't do the questionnaire by the time I took the data? So for this one, if we assume that there's 20 in the class, we just do 20 minus 16. So total number of students, oh, not 16, minus 14. So 20 minus 14 gives us 6. That must have been the people either away or who couldn't use the survey. Okay, not so hard. So just tally it up from your data, count the tallies to make your frequency, and you've got yourself a frequency table. All right. So the next thing we're looking at is graphs of frequency tables. So we're just going to be able to understand that a frequency table can be represented as a graph, and we're going to be able to construct those. So we're going to start with this. Here we've got a graph of the age of Australian Prime Ministers when elected. We've got a frequency on the y-axis and age down here on the x-axis. This example asks you to comment on the data shown on this graphic of the ages of Australian Prime Ministers when elected. If you'd like to do that now, give yourself a chance to kind of have a look at it, have a think about it, just pause the video. If you've got someone else there, maybe discuss with them, and then I'll unpause and I'll tell you what I think. So for me, looking at this, couple of things that we can notice. One thing I'd notice, the youngest anyone's ever been is somewhere in here. So, youngest PM, youngest Prime Minister had to be somewhere around 40 plus. And another thing I'd probably notice is that, we've got almost all of them fitting in here, this part. So most PMs, we might say, most Prime Ministers, most PMs, when they're elected, they are aged, about 50 to 60. So we can tell that from our frequency gap graph. You might realize that it's probably a bit of a more visual way to demonstrate these things than a table, especially one as shoddily drawn as my one there. So let's have a look about what we do with our graphs of frequency tables. They're relatively straightforward, especially if you've already got a frequency table ready to go. To turn it into a graph is not too hard. We put on the vertical, the y-axis, we show the frequency, yeah? And then depending on the data, sometimes you group values. So if it's numerical data, it can be good to group values. We've done that with our Prime Minister age, right? Each is grouped in 5-year gaps, 5-year bands. Now, if it's numerical data and you don't start at 0, we normally leave a small gap to the first column to indicate that you're not actually starting at 0. In this one, there is a bit of a gap. So yeah, we're showing that the minimum number is not 0, it's 40. Okay, so we're going to construct a frequency graph using the class's data. So I'm going to take my table here. Even though as rough as it is, I'm going to make myself a graph. This time I'm going to help myself out a bit. I'm going to put in some axes. So we'll keep it a bit straighter. So for here, it's categorical data. And my frequency, the maximum it can be is 6. So I'm just going to I'm going to give myself check marks up to 6. So 1, 2, 3, 4, 5, 6, trying to making them, about even in terms of height. And then I just need to put my categories down here. So I'm going to do, all right, so bicycle, it's here. I'm just going to write bike. And then next one is cars, just 1. Walking was 6 again. Try not to make yours quite as Leaning Tower of Pisa as mine if you can. And then the final one was tram. So we got that one, just 1. So all we're doing is we're just making on here, we've got the frequency on the y-axis, then we've got the category down here. That's so good. All right. Do I have any other data to look at? Oh, here's a bit of different data. We'll do this one, and that might help us seeing what it's like with numerical stuff. So first, we're going to construct a frequency graph, but first we're going to need a table. So I'm going to set myself up one of them. We got what shoe size are you? You guys, looks like the smallest one is 5, biggest one is 12. So we'll do shoe size. Yeah. We'll go 5, 6, 7, 10, 11, 12. Then what I'll do is I won't tally this time. I'll just count the frequency. That can probably be pretty okay. So if I look for 5s, there's only 1, right? So we've just got 1 there. 6s, 1, others, so 1 there. 7s, there's 1, it's just 1. 8s, 1, more 8s, so just 1, okay. So 9s, we got 1, 2, 3, 4, 5. 10, we got 1, 2. 11, we've got 1, 2. 12, we've also got 2. Okay, so I want to make my graph now. Let's go like this. So again, on the y-axis, you've got frequency. And on the x-axis, we've got shoe size. Good to label your axes, especially something like this. Now I'm going to have to do, all right, so the maximum my height goes is only 5, right? So I'll just do 5 check marks. 1, 2, 3, 4, 5. And then shoe size, I'm going to give myself a gap here. Remember how if we don't start at 0, we leave a gap. So here's 0, right? And then here I'm going to say is 5. So my first column there will be a gap. The rest, we don't need any gaps. 6, 7, 10, 11, 12. So all of these are going to be 1. So I'm just going to do this around my 5, 6, 7, 8, and then 9 is all the way up to 5. So we go there. And then we've got some 2s for 10 and 11 and 12. And then we've got a frequency graph of shoe size of the class. So yeah, we could notice some things, any interesting insights. Well, I mean, it looks like the people with shoe size 9 can swap shoes with each other the most in our class. That could be an interesting insight for us. Okay, so that is about it on graphs of frequency tables and how to make a frequency table in the first place. Thanks for watching.